Mm-hmm. There we go. Oh, everybody. I was talking for a good 10 minutes there before I realized that you couldn't actually see me. Hey, Mojo. Hey, Claire. Hey, Reno. Hey, male wife. How are you all? I was having conversations with everybody. I didn't realize that you couldn't see or hear me. Anyway, welcome to beautiful, scenic, lovely Lake Tahoe. I'm on the California side right now. Let me kind of turn this around so I can give you your bearings. So right now we're standing on the north shore of Lake Tahoe. There is the south shore. Way down there, that's South Lake Tahoe. That's west, that's the west shore. This is the California side over here. And that over there, off in the distance, those mountains are in Nevada. That's the Nevada side. If you see that little spit of land that's kind of jutting out over there, it's got all the trees along it. That is basically where the state line is between California and Nevada. So, if we wanted to, I could go walk to Nevada right now. But instead I'm going to hop in the car in just a little bit and we're going to drive to Nevada. I won't be live for that. But I thought on my way to Nevada, I might as well stop at Kings Beach, Lake Tahoe, and do a quick stream. Share one of my very favorite places in the world with you. So here we are. Yeah. Good to see you too, Optic Nerve. And I just drank a bunch of water, male wife. Yeah. Gonna go for a swim? No, Kitty Whiskers meal. Not today. On a different day I might. But not today. That's a really funny thing. So Lake Tahoe, of course, is like a really popular vacation destination now. Up until about the year 1950, nobody swam in Lake Tahoe. It just didn't happen. Lots and lots of people would come up here and they'd vacation, they'd visit, they'd hang out on the beach. They might wade out into the water, but nobody swam in the lake. And I wonder if anybody here can tell me why. It's a really stupid reason. But yeah. Let me know if you think you have an idea as to why nobody swam in the lake. Hey, Balint, how are you doing? Good to see you. Yeah. Hey, Dr. WD-40. Yeah, thanks. It was a lot of work to get this set up, but it's working. Yeah. How have you been doing, Dr. WD-40? Hope things are good. But I've been preparing for this great big cross-country road trip that I'm doing this summer, and I just left this morning. I'm heading out east across Nevada in just a little bit, and then I'm going to be streaming from Utah tomorrow. But until then, well, I thought I'd just do a quick stream here in Lake Tahoe first, and there are some friendly gulls right there. Hey, gulls. How are you doing? Are those western gulls? They're not ring-billed gulls. They're a little smaller than that. And, of course, there's a dog chasing them. Yeah. Let's see. No one in the Lake Tahoe area can swim, Miller. And it's not because of the Lake Tahoe monster, no. Good guess. Because dinosaurs would eat them. Good guess, too. And no, that's not a flamethrower. That's my signal booster. I need to paint that or something. Because I was walking here. Somebody out on the beach asked me, like, what, is that a flamethrower? Like, no, it's an antenna. But yeah. And hey, Kathy Duncan, how are you doing? Good to see you. And DK79, this is not Montana. This is still California right now. Yeah. Mammals bothering dinosaurs again. Yeah. Sound is really good. Thanks, Ironheart. Yeah. So yeah, the reason why nobody swam in Lake Tahoe until about the year 1950 is because of, like, basically like an urban myth.
do a research on that, Oliver.
Because Lake Tahoe is so high, this is a mountain lake, an alpine lake. I'm at like 4,600 feet right now, I think, above sea level. So for some reason, there was this, popular true fact that wasn't true at all. That because this was an alpine lake at such high altitude, that somehow the water would be less dense, and then it wouldn't be able to support you and you wouldn't be able to float. And everybody believed this until the myth was dispelled sometime around 1950 or so. So before then, nobody swam in the lake. They would go, wade out into the shallows, and they'd hang out in there, but nobody tried to swim, nobody walked, any deeper in the lake than they could stand up in, Because everybody was terrified of just sinking to the bottom of this lake, and it is a very deep lake. I think the maximum depth is about 1,645 feet. I think I have that right. Yeah. So yeah, people believe weird things. I wonder if there are any physicists or chemists who ever heard that and they're like, oh, of course that doesn't make any sense, but everybody believed it and they were scared to swim. Yeah, isn't that interesting, Yvonne? Welcome back, by the way. It's good to see you. Hope you've been doing well. Yeah. You can see them salting the lake for swimmers, Reno? No, never. Lake Tahoe is this beautiful, pristine blue lake. You don't want to put anything superfluous into the lake if you can help it. I'm very serious about that here. Because with just a little bit extra pollution, you could severely cloud the lake. You could really mess up the clarity. So I think it's a really good thing that people are so careful about that. Yeah. And hey, Smokes Games, how are you doing? Welcome back. Good to see you. Yeah. Hey, Nafron, what's shaking? Good to see you. So yeah, a few minutes ago, well, I thought this was live, but it wasn't. I asked the camera if anybody wants to hear the story of how Lake Tahoe came to be, like the kind of the geological tale that we can decipher from the surrounding rocks. How we got this beautiful lake way high up in the Sierra Nevada mountains. So give me a 3 in chat if you want to hear that. I'd be happy to do my best to tell it to you. But first I want to talk a little bit let's talk about the lake itself, and let's talk about the water quality, the clarity of the water. If you're anywhere on the west coast of the United States, you've probably seen bumper stickers that people have on their vehicles and stuff that say, "Keep Tahoe Blue." Lake Tahoe is really famous for the clarity of its water. And so Lake Tahoe has incredibly clear water, especially for a lake of its size. And there's a number of reasons why that is. There's a number of different factors that kind of contribute to that water quality, water clarity. There's not a lot of particulate matter in the lake. It's just almost entirely pure water, like 99.994% clear. Like if you were to, by volume, it's 99.994% water. And just the remainder is various minerals and organic matter and stuff like that. It's almost all just pure water. One of the reasons for that is that the lake is very, very deep. Like I said, about 1,600 feet deep at its deepest point. So it's one of the deepest lakes in the world. I think it's number 11 on the list of deep lakes. But also, a really special thing about Tahoe, something that I can actually show you. So you see how it's completely surrounded by mountains. There's just mountains on all sides. On the Nevada side, on the south side, on the California side. Mountains everywhere. So this is what we call a drainage basin. You can talk to geologists or hydrologists or other people about this, and they'll tell you all about drainage basins. The water flows downhill. So when precipitation falls in the form of rain or snow, you know, it naturally kind of seeks the lowest point. In the case of Lake Tahoe, there isn't a great big amount of surface area that's like land in the Tahoe Basin. The lake itself takes up the majority of the surface area. And so the majority of rainfall or snowfall that occurs falls directly onto the lake. So it doesn't have a lot of opportunities to kind of wash over the land and pick up all kinds of crud, particulate matter, organic stuff, minerals. Most of it is just pure water that's falling from the sky directly into the lake. So that's one of the reasons for the lake quality and clarity. And another reason, like I said, is the extreme depth of the lake. So if you do get sediment in there, it tends to settle way down to the bottom. And that means that Lake Tahoe is going to be around for a long time. Lakes don't last forever. As they get filled in with water, you know, water runs into them, sediment goes into them, sediment collects, and eventually lakes get kind of choked out by sediment. You know, if you have enough sediment deposited, eventually the lake disappears. It becomes a swamp or a marsh, and then it becomes a meadow. So if you've ever been in like a beautiful mountain meadow before, that probably used to be a lake at one point. Because Lake Tahoe is so deep and because the sedimentation rate is so slow, Lake Tahoe should be around for about another 3 million years, I've read. It's got a pretty long projected lifespan. So we got to make sure that we really take care of it. Don't pollute it. Don't fill it with junk. Oh yeah. How warm is the water during summer, Vagram? It's not that warm. Let me go down and touch it. It's still pretty cold because this is like runoff from the mountains. In the wintertime, the mountains are all covered with snow. And as things warm up, that snow melts and it drains down to the lake. And so it stays pretty cold. Not super, super cold, but, you know, cold enough. Let's see right here. It's actually really warm right here. It's just been sitting in the sun down here in this like little puddle. But if we were to go further out into the lake, it does get pretty cold. It's a very deep lake, so the surface might warm up a little bit, but you get like, you know, upwellings of cold water and yeah. But yeah, speaking of that kind of thing too, we're at the very warmest part of the lake right now as well. This whole, I forget what this is called, but from here in Kings Beach down over to like Tahoe City, this is the most shallow part of the lake. So you've got the most sunlight that comes through, and you know, with the least amount of water, it warms up pretty quickly. There is the deepest part of the lake on the other side of, see where the land juts out right there? On the other side of that is Crystal Bay, over by Incline Village, over on the Nevada side. And that is the very deepest part of the lake. I think just past where the land juts out, that's the spot where it's about 1,600 feet deep. But overall, the lake is very deep. It's about 900 feet, I think, on average. So yeah. Maybe that's why no one swims it? Yeah, Fogger. Deeper the water, the colder it gets. Pretty much, Erica, yeah. Yeah, you're right, for the most part. And what is that pipe, Claire? I think that is probably a sewage pipe. I think the water treatment facility is right up here. And so I think that is probably a drainage pipe. I don't know if it's still in use. But yeah. Everybody who lives in the Lake Tahoe Basin, ideally they're very, very conscious about pollution. Because that's why people come to this lake in the first place. That's why it's such a wonderful place to visit, is because the water is so clear. If you start polluting the lake, you know, kind of shooting yourself in the foot. And the clarity of the water is measured regularly. There's teams of people who do this, and they keep a very close eye on it. And they actually use a device that was invented specifically for Lake Tahoe. It's called a Secchi disc. So basically it's a well, you've got a rope, and then you've got what looks like a little white frisbee. I think it's made of ceramic material, like porcelain. And you lower that down into the lake, and then you just measure how much rope you let out until you can no longer see the disc. You know, it's a really bright color, it's bright white like that, so you should be able to see it really well. And so, you know, the lower you can lower down the Secchi disc and still be able to see it, the clearer the water is. So that's the way that they actually, you know, take measurements of the clarity. That's how they quantify that. Because as we know, science is all about quantification. Whenever we can get numbers on something, we try and do that. You know, try and reduce the subjectivity just a little bit. So, yeah, I think it was researchers from the University of California, Davis, who have a field station up here. They invented that means of measuring water clarity, which is pretty cool. Yeah. One pays that much to live on Lake Tahoe. I hope they keep it clean. Yeah, a little more. Yeah, you're right. I mean, well, and most of the economy around here is based on tourism. And so, you know, if people are no longer visiting because the water's all cloudy and filled with algae, you know, it's, you're not going to have as many people here, you know? It would not be a good thing, is what I'm going to say. Yeah. And right, Krokusty? It is beautiful here. Very lucky to be able to visit. I won't be streaming for too much longer here because I got to get on the road pretty soon. But yeah. Let's see, I'm trying to figure out that's where I came in, I think. Okay, cool. Yeah, how many people do we have watching right now, by the way? I can't see on the chat app. Yeah. And Zul, no dinosaur bones here on the beach. Definitely not. These are all igneous strata around here. These are all volcanic rocks. And that actually gives me a perfect segue to talk a little bit about the geology of Lake Tahoe and how the lake was formed in the first place. So this is an alpine lake in the middle of the Sierras, the Sierra Nevada mountain range. And Lake Tahoe is actually a fairly old lake. It's between about 10 and 20 million years old, we think. And it formed during the creation of the Sierra Nevada mountains. So as these mountains are building up, you know, you have got the Pacific, like the Pacific Ocean plate, is plunging underneath the continental North American plate, and that creates orogeny. It, you know, builds the mountains up. Because as this plate is going underneath, it melts when it gets into the mantle. It generates a lot of heat, and that heat's got to go somewhere. So it pushes up the mountains very, very slowly. Very slowly from our perspective, but relatively quickly, geologically speaking. Anyway, so as this mountain building is occurring, you've got this like volcanic activity that's happening around here too. And you've got, this basically used to be like just a valley in between these two different mountain ranges, between the Carson Range over there and between this range of the Sierras over there. And so there, you know, were glaciers here in the last, I don't know, few million years. Like during the last ice age, there were some huge glaciers in this area. And you also had some volcanic activity. And those two things kind of worked in conjunction to establish this lake. So what had happened, basically, from what I understand from geologists that I've spoken to, and from a little bit of reading that I've done as well, is that this kind of like big alpine valley in here got kind of blocked full with the glaciers. So it created kind of an ice dam, created a lake for a while. And then ice dams would break, and then you'd get huge torrents of water that would go down the Truckee River Valley, kind of carve that out. That's why we have these gigantic boulders in the Truckee River Valley, is they were carried there by these massive torrents of water. So this is kind of like an ongoing thing, a cycle that just continued. You had the like ice dams forming and then breaking again. But then I think around, I don't know when it was precisely. You could look this up if you wanted to. there was a big volcanic eruption from Mount Pluto. Mount Pluto is today a dormant or maybe even extinct volcano, but at the time it was very active, and so it created a lava dam. The lava flowed down through the same basin, solidified, and then cut off the flow of water, and hence you have the birth of Lake Tahoe. So it's kind of a story of, mountain uplift and ice and fire and lava. It's pretty dramatic. I'd love to learn a little bit more about that with the specifics, but that's the broad strokes of it right there. It's part of what makes this such a special place. And the rocks here kind of reflect that history. I'll see if I can find you a nice piece of granodiorite to pick up. But all of the rocks, almost all of the rocks in the Tahoe Basin are igneous. They're volcanic in origin. These are like some basalts over here. I might not be able to find any good granite here on the beach. Well, here's some. It's not super pretty. But take a look at that. So, can you see the kind of like shiny crystalline particles in here? Yeah, this is all a result of volcanic activity. Pretty neat. Yeah, I've got flecks of something in there. Might be pyrite. Iron pyrite. Fool's gold, or that might be something else. I'm a subpar geologist at best, as all of you know. But yeah. And Filthy Badger, how are you doing? Good to see you. Yeah. Quartz and pyrite, is that right, Reno? Yeah. Pretty cool, right? So a lot of the crystals that you find in the granite like that, those are quartz, I think, right? Silicon dioxide? I forget what the chemical composition is. Again, I'm more a paleobiologist than like a geological paleontologist. So yeah. Anyway, I'm gonna go ahead and wrap this up pretty soon and head back up to the car because I gotta get moving if I stand a good chance to get to my destination in Nevada at a decent hour. So yeah. Yeah, beach treasures indeed, Crocus. Alright, let's see here. I'm going to open up the Twitch app.
Hello,
and we're going to pay a raid
Jurassic Park.
to...
Because if they're
who
removed,
to?
America loses them. Correct.
I'll turn off the sound there. We're going to raid Cooking with Lord D. Or D. I always take forever typing on my phone. Yeah, there we go. Anyway, everybody, thank you so much for joining me here, beautiful Lake Tahoe. I'm going to get going and continue on this trip. I'm going to be streaming from Utah tomorrow, with any luck. Until then, everybody, you take care of yourselves, and I'll see you around. Let's go see what Lordy's up to. See you there.